Salzgitter AG is one of Europe's leading steel technology companies. It has long been involved in manufacturing heavy plate. And when it comes to delivering a variety of products for diverse applications, Ilsenburger Grobblech GmbH is at the center of attention. Salzgitter Steelworks, the biggest and most important supplier of slabs for Ilsenburg, produces more than 4 million tons of steel every year. In fact, steel of the highest quality is made here 365 days a year. The pig iron produced in 3 blast furnaces is delivered to the steelworks in torpedo ladles and desulfurized. In the Base oxygen converter, oxygen blasting oxidizes impurities and removes them from the pig iron, turning it into crude steel. During secondary metallurgy, the crude steel can then be adjusted for the analysis and temperature required by means of alloying, heating and vacuum treatment. Ilsenburger uses about half the 400 or so chemical compositions to make heavy plate. 3 advanced continuous casting machines are available to cast the liquid steel. Depending on the plate dimension required, the slabs are partitioned, adjusted and loaded for further processing following surface inspection. Ilsenburg is located on the northern edge of the Harz Mountains in Saxony-Anhalt, about 55 kilometers or 34 miles southeast of Salzgitter Flachstahl GmbH Steelworks. Every year, Ilsenburger rolls about 800,000 tons of heavy plate in all known grades, up to a maximum plate weight of 20.5 tons. The slabs produced in Salzgitter are delivered to Ilsenburg by rail. Following visual inspection, they enter the rolling program and are forwarded to the pusher furnaces on a pull-type skid conveyor. During handling, the size of each slab is checked by laser, while integrated scales are used to weigh them. The slabs are then pushed onto one of the 4 tracks of the 2 pusher furnaces using slab pushers. The slabs are transported through the furnaces on 2 skids per track. The stacks of slabs are pushed forward by the following slabs. The slabs undergo computer-controlled natural gas-fired heating. After spending about 4 hours in the furnace, the slabs are ready to be transferred to the rolling process. A discharging machine removes each slab and places it on the roller table. The heating process in the furnace and transport are monitored and controlled from a furnace control unit. The control unit also keeps tabs on 2 other heating furnaces, a bogey hearth furnace and a pit furnace. The descaling spray removes the scale formed on the slabs during heating in the furnace by spraying water through nozzles at a pressure of 200 bar. The rolling schedule is calculated during the transportation of the slabs to the roll stand from the following parameters: slab temperature and size, steel analysis, the rolling method selected, and the required size of the plate. 4-high rolling takes place as shown in this picture in the roll gap between 2 work rolls. The work rolls are positioned on backup rolls with double barrel diameter, enabling a rectangular profile to be produced in the plate. Ilsenburg produces plate with a thickness of between 5 and 120 mm and a width of 800 to 3,500 mm. The two work rolls are powered by the main drive with an output of 2 times 6,400 kilowatts via a spindle system. The combined hydraulic and electromechanical screw-down produces a maximum rolling force of up to 8,000 tons. The internally developed rolling schedule computer model is ideal for the production of plate with the tiniest thickness tolerances in terms of length and width. The thickness is measured in the middle and on both edges using isotope radiography. The dimension tolerances achieved on this extremely stiff roll stand set a new standard all over the world. After the rolling process, accelerated water cooling can be used to adjust the plate's mechanical and technological parameters. The ACC system is provided with data determined from the preceding rolling and other necessary parameters. The cooling model, which is the central module of a complex automation system, ensures the plate cooling process takes place completely automatically. Work is completed by a hot leveling process, hot marking on top and bottom, or stamping in a hot shear process if required. This is followed by cooling on cooling beds. Turning the plates over enables the visual inspection of both sides. Depending on the thickness, the plates are cooled in stacks before undergoing surface inspection. During cooling, the effusion of hydrogen from the plate takes place in order to prevent hydrogen-induced cracks. Ultrasonic testing is used to ensure the steel plate does not contain any internal defects. This is followed by customer marking complete with order data to identify the plate. In the shearing line, plate is trimmed down to a thickness of 40 mm and cut to length. Samples are taken to determine the plate's mechanical and technological parameters. For long-term marking, the steel plate can be stamped using the computer-controlled stamping carriage. Uneven plate and plate with internal stress undergoes cold straightening. Depending on plate thickness and the yield point, a straightening model calculates the optimum settings for the cold straightening machine. The broken and loose scale occurring during straightening is sucked off after the first straightening pass, and the plate is stacked out into the dispatch bay. All processes are carried out largely automatically. A number of furnaces are available for the heat treatment of steel plate. Usually, walking beam furnace is used, in which the plate is normalized, annealed or tempered without damaging the surface. This is followed by cooling on cooling beds. To produce high-strength steels, water-quenched and tempered maxial plate and wear-resistant Brenner plate, one of the most modern water-quenching units, is used. Following the austenization of the steel plates in a continuous furnace, the heated plate is transported into the quenching unit. Water is then used to harden the plate. The plate treated in this manner is now ready for further processing. For surface conservation, a shot blasting unit followed by a primer system are available. Precise weld edge preparation can be carried out on a milling machine for further processing. Plate can be subjected to a bending process. This is especially suitable for large tanks, enabling the plate to be used at the construction site immediately. In response to growing production volumes in recent years, in early 2005, Ilsenburger decided to open a new cutting and dispatch bay. As a result, Ilsenburger can easily process the permanently rising plate weights, especially for the wind turbine industry. In the testing lab, the steel characteristics set during production as specified by the customer, as well as in line with internal quality assurance, are verified. Tensile tests and notched bar impact tests are carried out on specific CNC machining centers. An impact testing machine combined with temperature-controlled and automatic sample feeder is available for notched bar impact testing. This allows the automatic testing of samples at a temperature range of +20 degrees down to -60 degrees Celsius. Conventional impact testing machines also enable testing for low temperature applications down to -196 degrees Celsius. In addition, tensile testing also takes place on automatic test circuits. Following the removal of the sample magazine, the sample is identified using a barcode system and measured. Testing is then performed automatically. All the parameters measured are forwarded to the quality control unit, and any residual pieces are then disposed of. The steel's hardness is measured on advanced automatic hardness testers, either as specified by the client or based on the Brinell, Vickers or Rockwell standards. Examining steel samples through a scanning electron microscope enables the surface to be seen greatly enlarged and reveals the elemental composition of tiny sections of samples. During thermal analysis, the material being examined is slowly heated or cooled down, enabling the transition points from solid to liquid and then gas to be determined. The chemical composition of solid and coated samples can be determined in next to no time using a glow discharge spectrometer. A light optical microscope is used to assess microstructures such as phase components, particle size, and percentage purity. The quality of the steel produced by Ilsenburg is confirmed by a verification of conformity with ISO 9001, along with a variety of product licenses and the recognition of independent testing and acceptance by various acceptance and classification companies. Plate is dispatched by a rail or lorry for just-in-time delivery to the customer for further processing. Each month, approximately 17,000 individual plates are sent all over the world for diverse purposes. The majority end up in Germany and elsewhere in Western Europe. Ilsenburg supplies more than 300 different types of steel. They include heavy plate for a huge range of applications and users. Apart from ensuring suitability for the purpose in mind, particular attention is also paid to making sure the steel is easy to process. Typical applications for quarto plate from Ilsenburg include steel girder and bridge construction, machine and vehicle construction, shipbuilding, pipelines and wind turbines. High-strength steels and wear-resistant steels from Ilsenburg in the Maxtil and Brina series are used, for instance, in mobile cranes, pressure pipes required in mining, and earth movers. By the end of 2007, around 600,000 tons of steel had been produced for nearly 5,000 wind turbine towers. These wind turbines generate a total of about 9,000 megawatts of electricity, enough to supply some 8.5 million households. Ilsenburger Grobblech GmbH, one of the leading manufacturers of plate in Europe in terms of both quality and its wide variety of products and applications.